So, dear colleagues, let me welcome you to the seminar of Moscow ACM Sigmod chapter number 245. And our guest today is Hamza Salem from Innopolis University. And his talk will be devoted to the precise main content and extraction from news websites. So Hamza, please, the floor is yours.
Thank you, Sergey, for the invitation. I will bother you a little bit with when I'm saying next, but
yeah, sure.
Like, sorry for that. So I will start. Thank you, everyone, for joining this talk. Today I will talk about my my thesis that I'm defending in Kazan Federal University. So my topic is algorithmic work for precise main content extraction from news websites. I'm defending this topic in 238 passport, and I will be talking about this topic in general, and I will be glad if I get some questions, feedback that I can go with it for the defense in January. Next. So agenda talk, this is the agenda. I will talk about myself, my supervisor. I will introduce the topic, the goal, objective, and tasks. I will talk about the algorithm that have been created during the thesis. I will talk about the results itself, the list of publication and abbreviation. Then I will end up with conclusions, some limitations, and I will open for question and answers. But also you always welcome to stop me and ask me questions. So the abstract for talk will be in these 5 points. So I will start with the focus. Focus is main content extraction. We will call it MCE, and in general, main extraction pages. And this problem is using web pages have a lot of noise, or let's say unrelated content, or like unimportant content in general that need to be filtered out. The solution is more like a simple mathematical model and an algorithm based on the DOM structure analysis in general. And the application for it will be the integration of this algorithm in RAS system, or retrieval augmented generation, and LLM models in general. And the result is what we will try to prove is the superior performance compared with some existing methods that we choose, like polar pipe and ability, some of the algorithms or libraries that actually like performed very good. Continue. So the introduction, I think in the beginning we have to start with this. The web is not usable, it's not used by only human or bots in general, or let's call it AI agents, whatever, but actually the main use for the web currently is the human. And usually in web we have what, like we when we open a page we will see a lot of information, but there is like a page that we want in general, and this is what you see in this article. If you open this website, you find that the article in the that you want, actually middle you have sidebars, you have headers, you have footers, you have a lot of and sometimes you have ads in top of it. And this will increase the necessity for extraction, or in general taking this information and filter it out and just find the relevant data in general. And for us as a human, we can literally read and what we want and consume what we want. But for machine, we have to develop softwares and algorithms to do that. And the main content isolation is not actually a new task, is a task that have been from the beginning of the internet from 2000. And that's why we will ask a question, why I'm tackling an issue that actually have been solved by like 20 years ago. And I think the main point is not solving the issue, but looking to the issue from another perspective, especially after the emerging of LLM. So the goal here is not actually just extract, but actually improve the efficiency in retrieval, in the retrieving of meaningful information from the web pages. Next. This is a screenshot for I will say three web applications that use LLMs: DeepSeek, ChatGPT, and Perplexity. And as you see, 3 of them have integrated a feature that called search. And this search is, if you think about it, a system that you can accept or can access the data in any LLM have some kind of an expiry date, like date that LLM do not know any information. That's why you have to integrate search or integrate the internet connection to it. And this is called RAG, Retrieval Augmented Generation. Next. So retrieval augmented generation is a system that used to reduce the what it's called the LLM hallucination. So when LLM do not know answers, it will hallucinate and just give you any information or any talk. And this hallucination is not like something weird from LLMs, but it's actually a behavior that exists in LLM. That's why we have what's retrieval augmented generation or RAG. And retrieval augmented generation, as you see in general, when you type a question and the answer is not in the LLM, the LLM will access some kind of a data or some information that's coming from a source. And this source can be stored, for example, in a vector database. And based on that, the LLM will access this information and put the answer and the question together and give a response. And usually, LLMs or RAG system in general, you can almost find it anywhere, and you will find it anywhere in general. And the main idea is you give the LLM prompts the answers. I inject the answers when LLM will ask a question. How this is connected to my thesis. Next. So as you see, LLMs are not cheap. And this is something that you all already saw. The business model for the current LLM or companies or AI companies is actually token based. And tokens is I will say the currency now is for LLMs. We have like a input token and output token, and you pay for both of them in general when you operate in LLMs. And think about it. We're extracting content in RAGs. We are extracting content and we inject it to the input prompt. So technically, you pay for each token. And why this is actually significant? There is 2 things. So the first one is actually the cost. And you will think about it and you will say, like, maybe it's really expensive. In language, it's very expensive. For example, I will tell from my language and also maybe Russian as an example, but from my language, Arabic, every letter is a token. So every letter, not every word. For example, in English, you can find it as every word, but in Arabic, every letter. And sometimes, as you see here, this is Arabic, and we have this concept. Each letter, we have what's called harakat. It's like a subletter, and this subletter can be always also another token. So imagine that this is this, like if you count this, it's more like the number of tokens. The number of tokens in the in one sentence in Arabic or in English, it will be very, very different. And this is a heavy cost in general in LLMs and in RAG system in general. And then one, the academic background in general. LLM hallucination as a I would say is already discussed in a lot of high impact journals, and the solution as a RAG and improving RAG is also discussed in these journals. Next. So if we will start with this, I think we have to start where the people actually finished. And I think the main point for us before we start implementing this, we have to check what is already implemented. And I think there is a lot of to do scraping or scraping fraud pages using algorithms or using even like some machine learning methods. And the main problem with all of these in general, there have been a good libraries. For example, PolarPipe is made by Google. Readability is like a Firefox library. Traveltura is also another solution. But the challenge is the first one is some of these methods are actually an ML based methods, so it's need resources to be run. And another one is increase the cost. The cost itself, for example, if you extract wrong information or extra information, you pay for it. That's why our algorithm will try to fit in this area, that we are trying to get a precise content extraction. So the goal for this thesis is to develop a cutting-edge open source algorithm for efficient and accurate web extraction. And here every word means something. So the first thing is we are doing this algorithm and we are comparing it with the open source algorithm that actually exists and actually have an access to the implementation, so we can compare it and make it after finishing make everything open source. The second is an efficient and accurate. It has to be efficient, so we should increase the efficiency in general. So even we can compare some method that have need a lot of resources, and our method should use less resources and also accurate. And accuracy is the main point that I will talk about it in the result. And all of this just to enhance the accessibility of the utility of web information globally. Next. For the thesis is to develop a lightweight, accurate algorithm to identify main content. And when we say lightweight that can be implemented in any language, and I will describe this more in next. And second one is to create a library for RAG-based system to reduce LLM token cost. And this is also one of the objectives. We are developing this to be integrated to RAG system to see the reduce of LLM token usage, and we already proved that and I will talk about it in the results also. And the third one is to advance the state of the art of the algorithmic approach in general for content extraction and set a new accuracy in and a benchmark. This is also a result of the study and an objective that we have been achieved in the end of the study. Continue. So what do we mean by lightweight? As I said, like no machine learning methods. We are not using training or model size. We are not going to the machine learning routes because we want to make it a lightweight that can be implemented in any language and can be integrated in any system. And the second one is a programming language independent. This is the main point for us, that can be implemented in any language that we choose. And what do we mean by accuracy? That we will be evaluated and measured per characters and per word. We will compare per characters for our results also. Next. So the classical heuristic approaches in general, I think before we start, as I said, like we have to do the literature review for this. And in general, as we said, the literature review for most of the systems that actually exist, there is a Plato finding algorithm. There is more like, this is like more an algorithm that used in the early content extraction method. There is a CCV, is like a content vectors. It's more like a structural analysis approach. The first one is more like the first one for the text in general. This more for the structure. The third one is called the content extraction via text ratio, or CTR. CETR is more like a text density based method. This is more focus with the text itself. And the fifth one is DOM tree density methods. It's also another one that relies on the DOM itself. And the fifth one is the word leaf ratio. It's also another statistical content identification system that actually relies on the statistical content identification and the statistical data related to where is the leaves and the words. And I can say that about all of them are a stepping stone for what we will build in the MCE. MCE is more like an algorithm that combine a lot of features from all of them. And I will talk about it when we will talk about the implementation. Next. And here is also, this is more like 2-3 slides just to talk about the key limitations. But in general, as I summarized, most of these algorithms are have some kind of limitations. And what we are trying to do is trying to reduce these limitations. For example, in the Plato, we relies on the raw HTML that, and we ignoring modern DOM structure. As I said, this is more like an early adaptation. And second one, the second one, CCV, is more like another case that actually can be fooled by large amount of in general, and some of it can actually work. For example, for comments and bars and navigation, sometimes actually can be fooled and cannot identify the main content. Next. And also similar to the others, as for example, for the CER, this is all focused on the text, sometimes can be fooled in some web pages that actually have a lot of text that actually not related to the main content. And also the DOM tree density method is also another one, can be also different. It can be also fooled with some areas in general. And the last one that can be also fooled by some modern like or complex web pages in general. Next. So as you see, I can conclude that most of these methods that we are trying to compare with, or at least the can be excluded from the beginning, that most of them have language specifics in general, limited also, and for limited adaptability to the diverse layout in general. And as I said, like most of them are a stepping stone for the algorithm that we are creating. Next. And now the modern approach and the libraries that we are after that we look for. So PolarPy is more like a one of the, I will say, the competitor that actually used in the study. And PolarPy, as I said, is developed by Google. It's more like a Java-based content extraction. There is a library in most of the languages, or most of the programming languages, like Python, JavaScript. Another one is called Web2Text, and also this is another library that actually it's a Python library that can also use for web content extraction. The third one is readability. It's more like a Firefox or Mozilla content extraction algorithm. And I think maybe some of you saw it in some in Firefox before Telegram introduced the quick read how can I say, like quick read feature. I think Mozilla Firefox, they did it inside the browsers, so they can identify the title and the body of the article, and you can just read it directly without opening the page itself. And the last one, Trafaltura, is also another Python-based web scraping and content extraction. The current challenges in general, inconsistent performance across different languages, as I said. And for example, Web2Text and Trafaltura perform this more, like there is some inconsistency in general, and high computational cost for token LLM applications. For example, if you integrate 4 of them to any RAG system, that you will have like some kind of a cost in general, or extra cost, because some of these libraries will just extract some irrelevant information that you need. Limited support for web layout complexity. And as I said, like web complexity of the web is something will just grow up, and this is something that to be updated every year or so. And lack of comprehensive evaluation dataset. There is no dataset or common dataset that you can test in top of it and see all these algorithms and how they can perform. Next. So the task for the thesis in general, we start with the state-of-the-art analysis. We have reviewed the techniques for the web in general, web content retrieval in general, and we evaluate what is the strength and weakness and the challenges in this field. And then we started with creating the novel algorithm that we have to design an open source application, open source algorithm that can have been outperform everyone, but also have to be a language in neutral model that can use any can be used in for any web pages that use any language, and also perform the high accuracy content extraction in general. And we have to use some features like text density, DOM depth, and node relationship in general. And we created also a benchmark or a data set that have more than 500 websites coming from Google Trends, scrape daily almost for every 3 months, daily for every 3 months, sorry. And it was like diverse languages. We used Arabic, English in general, and also like some articles have been in also some Spanish and some French content in general from Google Trends to test this generalizability in general. Next. And also we have to, after we finish with that, we have to add the practical part, and this is one of the most important things in the thesis, that we we apply what we got from the algorithm, and we put it in work in a RAG system that actually working, and we will talk about it when we reach it. But we implement the algorithm inside a Chrome extension to reduce token usage, and we evaluate based on that. So we integrated the algorithm after we created to this Chrome extension, and we saw how the cost will how the cost efficiency will actually work. And the main idea that also we have to enhance the cost efficiency for the tasks like summarization and information extraction that have been used in the Chrome extension. The fifth point is the accuracy evaluation. We have tested this algorithm against two, and we choose two, polar pipe and readability. If you remember, we talked about web to text and Terfaltura. We use polar pipe and readability because they perform better results than the others, and we kept it only for 3 methods, and these 3 methods should be open source, that you can also see the implementation. And the metrics that we implemented is the precision and recall and token saving in general. And the last one is this algorithm be an open source. We already put some part of it, like the implementation is actually open source, can be found in one of the published paper, but the dataset will be published after we will finish with the defense. And yeah. So now I will talk about the stages that we started with it. So we started, this is one of the first paper, 2022. This is the first paper that we published for this algorithm. And the main point was, this is the initial version of the algorithm. As you see, we build it based on how human actually observe web in general. As you see, if you look to this page, there's two things. You can identify as a human that the biggest text in a size is a title, and the biggest word count, dev, is a body. This is from how you look to it. And this was the first paper that we have published. The first paper that we created was a method that we construct, and we published the first version of it, and it was only on this observation. The observation of how a human look to web pages. And this is a little bit obvious, but it's also it was like the first step that we published. Next. So the version 2 is more like a refined version. We published this paper in 2024. It's called Mathematical Model and an Algorithm for Accurate Main Content Extraction from News. This one was more like built in a multiple hypothesis, but I'll talk about these, like the main hypothesis that we come up with from our analysis to the previous papers and also previous methods. So there's 3 hypotheses that we build the system in top of. The first one is called the structural hypothesis, and the first one is called main content in general follow some predictable DOM pattern, and this pattern that exists in the hierarchy. There is a structural analysis that can be done in multiple pages, and usually this is more related to content management system and how content management system organize the content, and we will talk about it when we'll start to the implementation. The second hypothesis is textual, and where it's more like related to the word density. If you remember when I talked about the first version of the algorithms that actually used this, and it's the textual is said where is the high word density, and with limited child nodes, and child nodes mean that this text is actually do not have child nodes in general. This means that this text is actually connected together, and this can be candidate for the main content in general. And the last one is a spatial hypothesis, that we in general we look to the center of the page. It's more like we as a human we look to the center of the page. So definitely the center of the page will be the main content in general, or the middle depth node in general in a web page. And this is something that also I will talk about it in the next slide. Next. So the main content extraction algorithm include 3 features. So the first feature was coming from I would say a standard layout that exists in CMS. And why this is actually work, and actually it's easy to look to it in general. Content management system, or CMS, is following following I will say best practice that's suggested by Google or any search engine in general. And one of them is to look to where is the I will say where is the node that have like many direct child or children's in general, and have higher direct children counts. So what's the meaning of this? This means that in this feature we are looking for the nodes that have like this node or a dev have children, and these children are direct children but also do not have how can I say children's. So technically it's just one node that have direct children without like other children's for the direct children's. And the main point here, we are looking for a structural hypothesis based on a CMS. And the CMS in general is more like an article dev, and this article dev or a tag that includes some paragraphs, and these paragraphs do not have direct children, but it's actually all of them are like children for one dev. This is the first feature. Next. The second one is called the maximum text without text containing children, and this is more like we identify where is the dense content in a block. So we look for a dev that do not have or do not have children, but it's actually have text, or without children that contain text. And this is also pretty obvious. We are looking for mostly old CMS and some of the websites that have just one big article that exists inside the page, and this article is just a pure text. And this is the main point for finding this div in general. Next. And the third one is the feature that coming from the spatial hypothesis. We are mimicking how human actually like focus, or how they focus, and we're looking here for the depth that actually closest to the middle depth in the node, or the depth in the tree of the page, or in the DOM in general. And I think this is just pretty obvious. We are looking for to the middle of the tree, and looking for where is the middle depth in general in their presentation for the web page. Next. So after that, we took all these features, we convert these candidate nodes to more like a 3D vector, and we have the child count, word count, and the depth as representation for these one. And then we calculate centroids for all these candidates, and based on our calculation, we select the node that have the smallest Manhattan distance to the centroid. And this is the main implementation for the algorithm. Continue. This is a representation for it. or the how the algorithm is actually work, and this is just a simple implementation to it, and just to show like what we're getting from this, how we parse the document, how we send it to the extraction, how we candidate, like find the candidates, and then how we can select between these candidates using the centroid method. The dataset overview in general, as you see, I mentioned the source for us was 500 websites or trending websites in general coming from Google Trend. And why we choose Google Trend? Because usually websites that will be cited from Google in Google Trends or any web or any aggregator in general, these websites follow the best practice, and these websites, everyone will try to mimic these websites because they are following the best practice, and we want to have an up-to-date best practice web pages that actually indexed from Google. And the duration for this was like we created this data set almost for 3 months, and we have like a daily script that actually scraping Google Trends for 3 months to collect all of this. And the purpose is also to create more like a benchmark to evaluate content extraction method. This is something that also I will talk about it in the result part. The purpose for this is not just creating this website, this data set, is actually making this data set as a benchmark for others to see it. And the key feature for all of this data set is we have to choose like a diversity of websites, multiple languages, also some complex tokenization, especially, for example, in Arabic. And the content type was article, blogs, and news. Next. Yes. And what we have been calculating, the main point for us was we are looking and we're counting how many words in general in each extraction. For example, this is representing the original text, and this is labeled by us. We calculated, and I will show how we calculated actually visually. And this is the count for the words count using the algorithm, and this is using readability, and this is using polar pipe. So the main point that we use is we use precision and recall and F1 score in general and accuracy for word count in a main content. And all the data sets have been labeled, as I said, by hand. We did it like by hand. Next. So the result of the data set, as you see, we almost hit 99% in almost every metric, and in precision, recall, and F1 and accuracy. And as you see, readability and polar pipe like also have good results, above 90 in general. But also, as you see, if you look to our results, it looks suspicious. Like, why this algorithm is just outperforming everyone? Are we customizing the database just to have a good result? This was one of the questions that we got in the beginning of the results during the seminars in Intel. That's why we have to perform another test using an external data set, and this is what I will talk about, and I will also explain the results, why we got like results almost perfect. Next. So after that, we choose another open source website, open source data set called WebZ.io. WebZ.io is more like an open source. You can search about it in GitHub. You can find it. It's a data source that have more than 1,000 web page in general. It's also have some kind of weekly releases. There is a new data set available every week. You can test it. And the focus is more like there is no the data set have like some specific themes, topics, and metadata in general, and also diverse sources in general. There is a lot of news websites. And after we applied the experiment using WebZ.io, I will show you the result in the next slide. Next. as you see, the algorithm still performed good, and also, but it's not like 99, but still it's actually better than readability and polar pipe. And the main point here, and this is the one of the things that we observed during this experiment. In the first one, we used Google Trend, and Google Trend almost all CMS that have been labeled as good good CMS, almost, or not good CMS that actually have a good SEO, they follow the best practice, and almost every best practice that actually exists in all of these websites in their CMS is used, or at least found in the first feature that are implemented. So technically, the first feature almost catch every website that have a good practice or a good SEO practice. That's why you see almost we have a perfect accuracy. But when WebZI is more like a news website that can collect from all websites that actually exist. So that's why the results have been more like more realistic and more show that okay, this algorithm is still better than the others, but also still that there is some web pages that do not follow maybe the best practice and do not have this like how can I say do not have like the algorithm catch accurate, and this is also very healthy for the research. And also, as an abbreviation for the work, we have integrated this work in a Chrome extension. This Chrome extension called Al-Katib. We have integrated our work or the algorithm itself, and we have integrated the algorithm and polar pipe and readability, and we have compared 3 of them for token saving in general. And as you see, this is what we got in general from, for example, the test run that we did. It was in GPT 3.5. It was like yeah, like 2 years ago, or almost like 2 years ago. And then we calculated how many daily saving tokens in general, and how the cost of the tokens, and we calculated the monthly cost saving in general. In this like this extension work for more like a summarization extension. And using this summarization, we just like this extension will summarize content, but have to detect it first, and then in the detection in the detection task, we have used the algorithm and we compare it with the others. Next. Another use case for the application, we have implemented the algorithm in another website to improve the SEO in general. One of the things that exist in web pages, an object called LD-JSON, or linked data JSON. And this linked data JSON is actually a representation for the page and what is inside the page. It will include, for example, the title, description, date, the body of the article. And what we did is we choose one website and we run this algorithm to inject automatically, without like without using someone, to inject automatically this JSON LD using the algorithm. So the algorithm will detect what is the title and what is the body of the article, and create the JSON object and integrate it to the page and publish it. And as you see, this is the indexing report in general. We managed to do it for almost 45,000 pages, and in the end, we got more than 40,000 pages that actually recognized in this website. And this website is actually live, and all of this dashboard, I also have an access to it as I'm owning this website. Next. So as you see, this is the conclusion for the talk. I can say that we have presented the novel algorithm that we have, fast, accurate, open source, and used in mostly like and outperform actually existing solutions in general and precision and recall and F1 and accuracy, and especially for English and some like the complex languages that have complex token in general. We created this dataset as a benchmark that can standardize this for the dataset in general, and can be used for comparison for extraction algorithm in the future. And the main point also, the efficiency that we got, we reduce the cost of using large language models by relying on these services, also integrated to multilingual websites and some websites that have implemented in Python, in script, and in client language and int-based languages that can be easily integrated to any web pages without like having like a supercomputer just to run this model. And the last one is the open collaboration. I invite researchers also to enhance this tool and also expanding this to have it for everyone. Everyone can contribute or build on top of it. Next. Next. Sergey?
Yeah.
Can you hear me?
Yeah, sure. So which slide would you like to see?
Oh, yes.
The
Yeah.
previous one or this one?
Previous one. Can you
Previous,
show me
okay.
43?
Yeah, sure.
There is some lagging. Maybe it is from my side. Let me check. Yeah. Yes. In 43, I just also clarify that dataset is. I'm getting multiple requests and regarding to the dataset that I will release in after the defense, and this is something that show that this other researchers that they want to build in top of my work. Next. So the current limitation for the work is, as you see, this is we have language constraints in general. For example, this is the work now is actually can work with English, Arabic, but does not work with Japanese and Chinese websites because they have a totally different structure and totally different way of web layout in general. That's why I will say this is one of the main points for us to maybe build on top of it or improve. The second one is, as you see, the website type restriction. Currently, we're more with the content-based websites like news articles, news blogs articles, and we are still cannot work with ad-heavy websites or e-commerce or even review-based websites, or even like some websites that have dynamic elements or non-standard layout in general. This is also another limitation. And future work that can be done, for example, Japanese or Chinese websites, or improve the handling of other type websites or other type of pages in general. Next. Thank you for listening. And if you have any questions, I'm ready to answer.
So, okay. Hamza, thanks for the talk. So, dear colleagues, do we have some questions to our speaker? Actually, I had a number of questions, maybe even dozens of questions, but it was about 2 months ago. And I already asked Hamza for these questions previously. So, and we can now test this work and this presentation for a new auditory, as I can see. So please, dear colleagues, if you have some questions, you're welcome.
Maybe I have a question.
Yeah, sure, Roman.
Yeah, about the kind of websites for which you can work. There are a lot of websites for now which are completely dynamic. They want a dynamic behavior whenever you are scrolling it up and down. The uses additional logic to download some more part of the information. So how do you process it?
Yeah. One thing that I mentioned also, thank you for your question. In the limitation, I mentioned that some of these websites that have dynamic elements or dynamic movement or non-standard layout, sadly, the algorithm do not have like support for this. Like this is one of the websites that, or the type of the websites that still till now we do not have support to it. And think about this algorithm is more like an algorithm that supports the content, direct content, for example, Medium or other websites that just relies on title, body. It's more like a rigid, I would say like a newspaper template, not like a dynamic, very dynamic elements that exist in web pages.
Okay. Actually, even in case of Medium, so you have just a part of information, and if you are not logged in, so you can see just some minimal part of the description.
Yes, yes. So yeah, in general, this is also one of the cases that also all of the websites that we have tested with it is more like an open websites that you can find everything in the HTML. Like you can find everything in the reloaded, the first reloaded HTML. And this is actually better for I would say for SEO. That's why also this is one of the bias that I can say in our data set, that we looked for the website that have good SEO, and most of these websites that have good SEO, they follow this, like everything is open, everything can read it, and it's a title and body only.
This is true, but the reason why websites are so complex, that is to prevent automatic collection of information. So if
Yes.
the website is completely open, in this case, there is another question. Why don't you use RSS format to just read the stream of news, or, for example, read it from Telegram or from another source?
Well, the RSS feed, the website should support RSS feed, but what do you mean by Telegram?
Telegram that is one of the source of news channels. I don't know how often it is used outside Russia. For example, in Russia, that is a very common source of information, because you can just subscribe on the channel and read directly from the channel. So it's some kind of RSS feed, but a very convenient tool for reading news.
Good, good. I think what they are using is actually using something similar to it. I remember I saw it in, I think, I'm not sure if we mean the same thing, but is it like the quick read feature that exists in Telegram that you click on the website?
The most closest analogy of this that is reading from Facebook or LinkedIn.
But just let me just describe the feature, because as I remember, this feature is actually built by Firefox. It's like a called quick read. You do not open the page, but technically you open a browser, not a browser. It's maybe like a page inside Telegram, and in this page you just see the title and the body. Do you mean this?
No, actually, I mean, if you need to get some collected information about news, we can take different ways. We can select different sources of this information, and information may be present by different ways, like RSS feed, like feed in again like in Meta and LinkedIn and Telegram or somewhere else. So the question is more general.
Understood.
So can you work with that as a common approach, or okay?
Yes, understood. I think, yeah, but the main point here, we try to implement a system that can fit with most of the, like I would say, the internet of or websites that exist on the internet that provide news or blogs or in general that content based. And the main point was not getting this information, but getting it in a way that can be efficient, accurate, but also open source. This is something that also I mentioned in the beginning, that there is actually some solutions that you can pay to it for. I think Traveltura is one of the one that actually have paid, so you can pay and use it. For example, you can pay to it, and you can just send the website, and they just retrieve you a JSON, and the JSON include everything. So this solved the problem of extracting. But the main point for the thesis here we have to do it open source, we had to do it lightweight, and we had to do it efficiency, like we have to compete with efficiency, but also we have to beat what exists in an open source method that actually exists. So the main point was like try to fit all of these points, not just taking the content.
Okay, thank you.
Okay, so dear colleagues, do we have more questions? Okay, I do not see any raised hands. So so maybe okay, I have a questions concerning the future work. So we can see that actually the title or the work, yeah, the main topic is not very wide. Yeah, it's a bit narrow, that it works best, yeah, as you mentioned, on content based websites, and you put the news websites right in the title of the work or the thesis. But okay, as we can see, you do have in mind some future work. So could you please shed some light on the ideas or the extension or the method on the other types of web pages? So probably you should add some new features additional to the third features that you already developed in your thesis, or maybe you should provide some new ways of combining these features. So is it possible right now to give us some intuition of the future work?
Yes, I think the future work I started with like it was not included in the thesis because it's also out of the technically the work itself, but I can tell you like currently we are building like I say a version from it that can recognize if this is sites for news or something else, and if it's something else, we follow pattern in general. The e-commerce or I would say review or like e-commerce and adding. This is two categories that we're trying to tackle. And as you see, both of them somehow have this structure of repetition in general. For example, in e-commerce, you will have multiple products. So there is a pattern that you find in general that these actually products that because they follow the same layout in general. Similar to it with ad listing, similar to it with ad listing. But in general, the main point was adding like something like in top of it a router that can detect what type of page and then try to extract it, because the algorithms actually work in the details of these websites. For example, if you open a product page, the description, the main body of the description for the page will be the main content, but it's not only the main content. You have to also add some other filters in general. And similar to it, the ad listing website like Avito or also they have in the detail page, they have almost some similarity with the content page with images and something else. So I think this is the where we can go. I think there's also another direction is to try to support Chinese and language or Japanese, but I think this one will be very hard even to try to implement, and we have to have like some kind of motivation to do it, because in this website web is literally different. It's totally different. It might be something from scratch, like something else.
Okay, thank you. So do we have some more questions from the auditory? So thank you.
Thank you for inviting me, and thank you everyone for listening. Thank you.
Bye.